Hi, hello dear students. Welcome to Karnataka SSLC classes. In this video, we are going to study about the very important theorem which is called basic proportionality theorem. It is also called Thales theorem. Okay, and it is an important theorem because in most of the exam papers of 10th class, you can see the basic proportionality theorem was a regular question. Okay, and with the help of BPT, you can even understand how to solve the questions. Okay, so we'll start with the BPT. Okay, so before start with the BPT, in the last class we have seen what are called to be similar figures and also similar triangles. So how can you say the two triangles are similar? Okay, two triangle similar and ಹೇಳ್ತೀರಾ? So I told you with the help of two conditions, if two conditions are satisfied, then you can say the two triangles are called to be similar. What is the first condition? The two triangles should have their corresponding angles equal. Okay, suppose if I take triangle, okay, let me take one triangle and one more triangle. Okay, one more triangle. Okay, now you can see in both these triangles, okay, the corresponding angles, if I take corresponding angles are equal, okay, okay, then I can say, okay, I mean this first condition is said to be satisfied. Okay, suppose the first triangle is A, B, C, second triangle P, Q, R. Okay, so I can say if, okay, if angle A equal to, okay, angle P, angle A equal to angle P, angle B equal to angle Q, okay, angle C equal to angle R. Okay, if I write for these two triangles the corresponding angles equal, okay, and second condition, their corresponding sides are in the same ratio. Suppose if I make use each side as 2a, okay, each side as a so I am taking different triangle, not equilateral. So suppose it is 2a, for example. Okay, let me take this as an equilateral triangle only. Okay, 2a, okay, and it is a. Okay, now, so if you take the ratio of corresponding sides, okay, 2a by a, okay, for each corresponding sides ratio is 2a by a, it means a get cancelled, you will get a 2 by 1. Okay, it means AB by PQ is equal to BC by QR is equal to CA by RP. Okay, so the corresponding sides ratio is also going to be same. Okay, so such two triangles where the corresponding angles are equal and corresponding sides are in the same ratio, they are called to be similar triangles. Okay, so both the conditions should be satisfied in order to say the two triangles are similar. Okay, so we'll go to the actual topic. So before we go to what is called to be BPT, so we'll do a activity. Okay, so the activity says about the principle of BPT. Okay, so let me consider a straight line. Okay, let me consider okay, a ray. Okay, and one more ray which makes an acute angle, okay, now I'll name these. Okay, okay, let me say, okay, AX is a ray and AY is also a ray which makes some angle here. Okay, now we will divide AY into 5 equal parts. Okay, it means first I will set the points. Okay, point 1, point 2, point 3, point 4, point 5. Okay, so I will fix 5 equal points. Okay, let me say these as, okay, B1, okay, B2, B3, B4 and B5. Okay, so I have made a ray make some angle with the horizontal line and I have marked 5 equal points. okay, 5 equal points. Now you can join from the point B5 to any point on the line AX. Suppose this is a point, okay, and I'll join, okay, I'll join the lines, okay, I'll join the lines, okay. So this is a line, okay. Now again I'll join one more line from, say for example, B3, okay, B3, okay, B3 to any point on the AX, but it should be parallel to the other one, okay. So I'll name this, okay. Say for example it is C, okay, say for example, okay, it is C2, okay, it is C1, okay. So you have to draw a line from the remaining 4 points, okay, which is parallel to B5 C1, okay. We know that these 5 points are with equal distance. It means from A to B3 how much? A to B3, okay. If I take ratio of A to B3 by B3 to B5, okay, okay, it is going to be first 3 units, okay, 1 2 3, okay, 3 equal units, isn't it? So 3 by, what about B2 to B5, B2 to B4, 4th unit and 5th unit. So here only you can consider 2 units, isn't it? So it is 3 by 2, okay. So A to B3 and B3 to B5 you can consider as a 3 by 2. Now if you measure AC2, okay, by C2 C1, okay, if you measure AC2 by C2 C1, again you are going to get 3 by 2, again you are going to get 3 by 2, okay. So here this principle used by Thales in order to construct or in order to define the BPT, okay. So this activity helps in order to understand what is called a BPT, okay. So here importantly the line which you are connecting from the first line to the second line, okay, that line must be parallel to the one which you are drawing, okay. So if it is not parallel, then you will not get the same ratios, okay. In order to get the same ratios, the line should be parallel to the other line, okay. This is the idea behind the BPT, okay. Next one. Now very important, basic proportionality theorem, okay, BPT in short, and it is also called by Thales theorem because it is introduced by mathematician called Thales, okay. Now as per this, what the theorem states, you see, if a line is drawn parallel to one side of a triangle to intersect other 2 sides in distinct points, okay, the other 2 sides are divided in the same ratio, okay. So here you need to break this statement in order to understand what is saying. First let us consider a triangle, okay. So roughly I'll just explain. So you consider a triangle, okay, consider a triangle, you draw a line parallel to any one side. For example, if I say it has A B C, okay, I'll draw a line, okay, parallel to BC, okay, parallel to BC, okay, parallel to BC, okay. So this line which is parallel to BC will intersects AB and AC as other 2 sides at different points. Distinct means, what do you mean by distinct? Distinct means it is different at different points, okay. Then the other 2 sides are divided in the same ratio. It means, suppose if I name this line as, okay, D and E, okay, then the 2 sides are nothing but AB and AC are divided in the same ratio. It means you should get AD by DB is equal to AE by EC. So this you need to prove, okay. So first we will write what all needed to prove this one, and we will go with the actual derivation part, okay. So here idea is, again you need to find the area of a triangle, okay. To find the area of triangle, how do you find area of triangle? It is half into base into height, okay. So with the help of area of triangles by taking ratios, we can get this theorem result. Okay, we'll see. चलो ठीक है, we'll prove. Okay, so we'll prove the theorem. Okay, okay, yes, proof. So we'll start with the consider a triangle ABC. Okay, we'll consider a triangle called ABC. Okay, then okay, draw a line say DE. Okay, it is a line, okay, say DE parallel to, okay, say for example BC, parallel to BC. Okay, intersecting at D and E, okay, for the lines AB and AC, okay, respectively. Okay, it means you can find D on the side AB and E on the side AC. Okay, now what you need to prove, so that we will also write okay, to prove, yes, I told it is AD by DB equal to, okay, AE by EC. Okay, I'll draw figure also. Okay, I'll draw figure. Okay, I'll draw figure. Okay, so we'll name this a triangle. Okay, so it is ABC, ABC. Okay, so there is a line, okay, there is a line which intersects okay, AB and AC, which intersects AB and AC, okay, at point D and E. So this DE line, okay, this becomes now line segment. So this DE is parallel to BC. Okay, and what we need to prove, that AD by DB, okay, AD by DB is equal to AE by EC, AE by EC. Okay, fine, we'll continue in the next page. Okay, so we'll draw one more time the figure. Okay. Okay. Okay, so we'll name A, B, C. Okay, so line, okay, a line, okay, excuse me, take, okay, so there is a line, okay, which is parallel to BC and intersecting AB at point D and intersecting AC at point E. Okay, fine. Now for our result to be proved as AD by DB and AE by EC, we need to do some changes, some construction part. Okay, so what we do, we, as I told you, you need to prove this BPT with the help of area of a triangle. So when you find area of triangle, you need height. Okay, height of a triangle. Okay, so here first we need to join BE. Okay, so we'll write join BE, okay, and DC. Okay, so I will join both. Okay, So I will join BE and DC. Okay. Now I also want height of the triangles. Okay. So to get the height of triangles, okay, suppose here triangle is ADE. Okay. So for the triangle ADE, I want height. So again I'll consider height. Okay. Some height I'll consider. So this is the height of the triangle. Okay. And again for ADE, on the, if I consider AE as base, so let me consider one more. Okay. One more height. Okay. Done. Okay. So here it makes a 90 degree. Okay. Okay. So let me say it is N point. Okay. And it is as a M point. Okay. We can make use of any letters. Okay. Fine. Now, so the same thing we'll write. Okay. Now, draw. Okay. Draw NE. Okay. Perpendicular to AB, and okay, and DM perpendicular to AC. Okay. So I am drawing NE perpendicular to AB and DM perpendicular to AC. Okay. So now we will try to find the area of triangles. Okay. So first, so we know from the previous class, area for triangle you can write as, okay, area means AR bracket, triangle, suppose ADE I am finding. Okay. Area of triangle ADE, yes, tell me, it is half into, okay, base into height. Okay. So I will write formula once. Next time you need not to write a formula, you can just substitute. Okay. Now, so half into. So for the triangle ADE, okay, on which side you can find a perpendicular line? On the side AD you can find a perpendicular line. It means AD becomes your base. Okay. So base is AD. Okay. And a perpendicular line always gives you height of that figure, height of that triangle. So your height is EN. Okay. Or I'll write a NE. NE. Okay. So call this as equation 1. Okay. Similarly, I'll find okay, area of triangle BDE. Okay. BDE. You can call triangle in any way. Okay. With you can start with EDB or DEB. That is okay to call the triangle. Again for this triangle, you can find that there is no perpendicular line in this BDE triangle. For such a triangle, the perpendicular line height can be outside of the triangle. So for BDE, the height is actually outside of the triangle. It means height is again EN. Okay. The height is going to be EN or NE. And base is going to be BD, because extended length of BD only we are finding the height. It means base is becomes BD. Okay. So I'll write half into BD as base, height as again NE. NE. Correct? Am I right? Okay. Next. Similarly, I'll find area of triangle again ADE only. ADE. But this time I'll consider AE as base, because I can find one more 90 degree here. Okay. So on which side there is 90 degree, that can be considered to be base. Okay. So area of this triangle ADE again half into, okay, base is going to be AE, because on this side only we have 90 degree, and height of that is nothing but even DM. DM. Okay. Height is nothing but DM. Height is nothing but DM. Okay. Sorry. Okay. Height is DM. Okay. Into DM. Okay. Call this as equation 3. Okay. Similarly, here one more triangle is left. Triangle DCE. Okay, so again I'll find the area of a triangle, okay, DCE. Okay, DCE. Tell me, for this triangle there is no 90 degree, there is no perpendicular line inside the triangle. You can find outside. Okay, there is a 90 degree outside of this triangle. It means the base is going to be EC and height is going to be again DM. Okay, so half into, okay, base is EC. Okay, EC, and height is outside of this triangle, which is again DM. Call this as equation 4. Okay. So now what you have to do to get the result, you have to divide the ratios. Okay, you have to divide these areas. Okay, so I'll divide, okay, 1 divided by 2. Okay, equation 1 divided by 2. Left hand side it is area of triangle ADE, okay, divided by area of triangle BDE. No need to use triangle symbol. This is a way of representing area of triangle. AR, just you have to write a triangle name. Okay, it is on the left hand side. Yes, tell me on the right hand side. So after writing, half and half get cancel. Okay, and NE get cancel, you will get AD by BD, isn't it? So I'll write after dividing, you will get result as AD by BD. So this is one of the important result. I'll call it as equation A. Similarly, okay, on the right hand side of the triangle also I'll do the same division, like equation 3 divided by equation 4. Okay, left hand side it is, okay, area of triangle ADE, okay, divided by, okay, area of triangle DCE. Okay, right hand side half and half get cancel, DM and DM get cancel, you will get, okay, AE by EC. Again, this is an important result, call it as equation B. Okay, now so I told you our actually result of proving is AD by DB equal to AE by EC. AD by DB equal to AE by EC. See, this RHS part can be said to be equal only if LHS part are equal. You can see here AD by BD, but here AD by DCE. Okay, so numerator is same, but denominator part you can see, okay, denominator part are different. So if denominator parts are same, then I can say LHS part are also going to be equal. Suppose if I say area of BDE is same as area of DCE, then I can say LHS part are equal and hence RHS part are also equal. So is there any way or any method by which I can say these two areas are same? Area of BDE, okay, this one BDE, and area of DCE, are they equal? Yes, they are equal. Okay, so I can write area of triangle BDE, okay, is equal to area of triangle DCE. But I can't simply write, I need to write a reason. Why? Because areas, okay, areas formed between same parallels and common base is equal. Okay, so try to understand. See here BDE and DCE, both they are formed on the same base. Which is the base? Base is D. D is the same base, because on DE only, okay, on the side DE only you can find first triangle, okay, and you can even find this second triangle. Okay, so DE is common, and we already said that DE is parallel in the construction part. Okay, and it means these two triangles are between two parallel lines. Okay, so if triangles are formed with one side common and between two parallels, here parallel are DE and BC, so the areas of such triangles are going to be same. Okay, areas formed between same parallels and common base is equal for this triangle. Okay, so it means I can write in the place of BD equal to DCE. Okay, so I'll call this as a result. Okay, C as a C. Okay, fine. So at last, okay, using this result, okay, using this result either in A or B, or you can compare. Okay, so I can write okay, so I can write okay, so I can write from A, B and C. From equation A, B and C, if you compare, in the place of DCE, I can write a BDE. Now the LHS part are going to be exactly same, and I can say the RHS part are also going to be equal. When I say from, I'm comparing equation A, B and C. So the outcome will be the RHS part are equal. So AD by DB, okay, is equal to AE by EC. E by EC. So this is our required result. Okay, so this is about the BPT. So here the important thing is, for a triangle there should be a line parallel to any one of the sides of the triangle. Okay, if it is a parallel, then I can say the other two sides make a equal ratio. Okay, the intersecting sides will make the same ratio, as we did the intersecting lines are AB and AC. Okay, so they divide in the same ratio, as AD by DB is the same as AE by EC. Suppose AD by DB, okay, suppose AD by DB is 3 by 2. Okay, then what about AE by EC? It is also 3 by 2. AE by EC is also going to be 3 by 2. Okay, so this is about a BPT. So once you understand BPT, you can even understand the converse of BPT, which is also very important, converse. And we have one more result which is called corollary of BPT. So all these three are very important for the exam point of view. Okay, so in the next class we will do some questions. Okay, I'll select some important questions maybe from the exercise. Okay, and try to understand the BPT and its related questions. Okay, so thank you, keep watching, keep sharing and keep supporting. Thank you.